Hi, and thank you so much for joining me today. My name is Caroline Wong. I'm the Chief Strategy Officer at Axari, and I'm delighted to present today's keynote on the rise of agentic AI, rethinking security programs. Let me see. Before I dive into the presentation, I do want to let you know that I wrote this book and it was published recently. I actually wrote the AI Cybersecurity Handbook between January and September in 2025. And then when it was released last month in March, it was already out of date. But that being said, I still think it's good. I highly recommend that you go out and get it. And actually, my talk today will be talking about some of the things that have happened since the book came out. When it comes to agentic AI, and cybersecurity, everything is sort of very up to the minute. Um, at this particular moment, everyone is talking about mythos. Is it dangerous? Is it overhyped? Is it a breakthrough? These are all reasonable questions. But I actually think we've been asking the wrong questions. The real question, from my perspective, is why are we still surprised when this happens? Because if we take a step back for a moment, we can say that this actually isn't new. This is not a one-time event, and this is not a singular breakthrough. This is a pattern. My good friend, and one of my very favorite thought leaders in the cybersecurity and in the AI space, Daniel Miessler, made this point really well a few days ago. His argument essentially is that mythos isn't the story. The reaction to mythos is the story. Because if we keep treating each of these jumps as a singular event, when the honest read is that they're a pattern and one that's going to keep compounding, Daniel uses an analogy that I think is exactly right. We are still in the vacuum tube phase of AI. We haven't even hit transistors yet, which means that the capabilities that we're reacting to today is actually the most primitive version of it that we will ever see. Models are getting better. Models are getting better. The foundational models are getting better and better. They get better and then they get meaningfully better. And then every once in a while, they get a lot better. And that's not going to slow down. If anything, it's going to happen more frequently. So, what's been interesting to me over the last couple of weeks in particular isn't just the technology, it's how we're all reacting to it. Some people are looking at this and saying this is overblown. We've seen this before. Others are saying this changes everything. And some are trying to figure out how to control it, how to operationalize it, how to get ahead of it. All of those reactions make sense. But here's the problem. The technology doesn't care what stage we're in. It's going to keep moving and it's going to keep improving and it's going to keep showing up in ways that feel sudden. Even though if we're honest with ourselves, they really shouldn't be. So instead of asking ourselves whether something like Mythos changes cybersecurity, what I want to do today is step back and take a look at what's actually happening. Because there's actually two things happening at the same time. And the risk doesn't come from either one on its own, it comes from what happens when they collide. Let me give you a simple way to think about what's happening. There's two curves happening at the same time. Most of our conversation right now is focused on one of them, but the actual risk comes from the interaction of both. The first curve is the one that everyone's talking about. It's the curve of AI capability. It is steep, it is accelerating, and it's getting a lot of attention. The second curve is quieter. It's the curve of how our organizations actually operate, how well we understand our environments, how fast we can respond, how mature our processes really are. And that second curve is moving, but much more slowly. Individually, neither of these curves is surprising, but when you put them together, you can start to see the problem because the risk is not just that one capability curve going up and to the right. It's that these two curves are moving at very different speeds. And that gap is where things start to break. So let's take a closer look at this first curve, which is capability acceleration. This is the one everyone's focused on. This is the AI capability curve. And to be very clear, this curve is absolutely real. What we're seeing right now is not theoretical. This is not future looking. This stuff is already happening. And the simplest way to understand it is this: AI is compressing time across the entire attack lifecycle. Manual things that used to take days, weeks, or required very specialized expertise are now happening faster, more consistently, and with far less effort. The Cloud Security Alliance CISO community, SANS, and the OWASP Gen AI Security Project put out a joint briefing on this a couple of weeks ago. They called it the AI vulnerability storm. And the specific data point they lead with is this: the time from discovering a vulnerability to weaponizing it has collapsed from weeks or months to hours. And that's not a forecast. That's where we are right now. Let's talk about vulnerability discovery. AI can scan large code bases, identify patterns, and surface potential vulnerabilities much faster than humans. Not perfectly, not completely, but fast enough to change the economics. Next, let's take a look at exploit development. Once a vulnerability is identified, AI can help reason about how it might be exploited, what conditions are required, and what techniques might work. Again, not always end to end autonomously, but still significantly faster than before. And third, let's consider attack orchestration. We're no longer talking about one person or even one group running one exploit against one system. We're talking about automation, chaining actions, and scaling across environments. Increasingly, these aren't just tools assisting a human. These are systems that can take action, chain decisions, and operate with some degree of autonomy, not fully independently, but far more autonomously than we've seen before. And that's what a lot of people mean when they say agentic AI. So when you combine these three things, discovery, exploitation, and orchestration, you get a very different dynamic. The cost of finding and exploiting vulnerabilities is collapsing. And when that cost collapses, you don't just get better attackers, you get more attackers, more attempts, more surface area being tested. And I want to pause here for a second because this is not about one model. In my opinion, this is not about Mythos being uniquely capable in any sort of isolated way. This type of capability is uneven, it's inconsistent, and it's distributed. There's an article written by Stanislav Fort with IL Security that I think is one of the sharpest takes that I've read. It's called The Jagged Frontier. And Stanislav's point is that AI cybersecurity capability doesn't scale cleanly with model size or cost. Smaller, cheaper, and even open models can potentially replicate a lot of what Mythos does on vulnerability analysis. The rankings for any of the models reshuffle depending on the task and depending on the moment in time. There's a line in this blog post that talks about 1,000 adequate models beating one brilliant model. Because when the cost of scanning drops far enough, then you stop prioritizing what to look at and you just look at everything. In some cases, smaller, cheaper models can already identify vulnerabilities, reason about exploitability, and contribute meaningfully to this process. And we know that attackers likely already have a lot of access to this capability. So it's not so much of a step function, it's an acceleration curve. This acceleration curve has been building, it's been improving, and now it's starting to compound. So then the important question becomes, if this isn't entirely new, then why does it matter now? This is where it does matter. Scale. More code can be analyzed, more systems can be targeted. Speed, the time between discovery and potential exploitation is shrinking. Accessibility, capabilities that used to require deep expertise are now widely available. And when you put those together, then more people can do more damage much faster than they could before. Not because they're more sophisticated, but because the system is more efficient. And on its own, that would already be a meaningful shift. But that's only half of the story because this first curve doesn't exist in isolation. Let's talk about the second curve. And here I want to talk about organizational reality. This is the one that's harder to talk about because it's not about what the technology can do, it's about what we, security teams, security programs, can actually handle. So instead of talking about models for a second, I'm going to ask you at your organization, in your security program, do you have a complete and accurate asset inventory? Because we've been trying to build that for like 2 or 3 decades now. Do you understand the dependencies across your systems? If something is deployed and then breaks, do you have a reliable way to roll it back? I'm not talking about in theory, I'm talking about in practice. So many organizations cannot answer these simple questions with confidence. And that's just the state of most environments today. It doesn't help that for 4 years in a row, so many security programs are being faced with budget challenges and being asked to do more with less. Many of the environments that we're responsible for as security teams are complex, interconnected, constantly changing, and only partially understood. In most organizations, asset visibility is incomplete. Data flows are fragmented and not entirely clear. Integrations are changing all the time and somewhat fragile. Shadow IT and now shadow AI exists everywhere. And even beyond that, most real world attacks that are successful don't just rely on vulnerabilities being exploited. They rely on identity, compromised credentials, phishing, social engineering. There's a whole chapter in my AI cybersecurity handbook that talks about how phishing and social engineering is getting so much better. Deep fakes, voice phishing. I actually think that today it's not even possible to identify a scam message based on something like a misspelling or a grammatical error or like a funny looking graphic because all of this stuff is just so good today. I actually think that the best recommendation that we can have for ourselves, for our families and communities, for our organizations, when it comes to social engineering, is when I receive a message that I didn't expect, particularly one that has a sense of urgency, then I have a responsibility to validate that message via a second channel. Anyway, back to our topic. Most real world attacks don't rely solely on vulnerabilities, they're actually relying on identity. So, another aspect of this mythos conversation is the question of, are we actually focused on the wrong bottleneck? What if vulnerability discovery isn't the most important thing to pay attention to because it's not what's breaking organizations today? Historically, the majority of serious security incidents, they don't start with a 0 day. They actually start with credential compromise. And finding vulnerabilities has, I don't know if we could even consider that to be a real constraint. We know how to find vulnerabilities. What's hard is fixing vulnerabilities. It is really hard to fix vulnerabilities at scale in legacy environments with limited engineering capacity. So, this is a way of looking at security actually not as a vulnerability discovery problem, but as a labor and resource problem. So, for as long as we're still focused on automating vulnerability management, attackers are still compromising our credentials and walking in through the front door. At this point in time in 2026, many security organizations don't even understand our environments well enough to automate them safely. And even if we did, there's a human constraint because security teams are mostly always operating near or at or beyond their capacity. And now we're asking them to try and handle fixes for more vulnerabilities, faster timelines, more complex systems, while integrating entirely new AI driven workflows. The world and the environment and the technology that we're using today is operating at machine speed, but security is still operating at human speed. And that matters because no matter how fast the technology gets, humans still need to make decisions, changes still need to be validated, and systems still need to be understood. Those are things that don't scale instantly. And there's a second order effect on top of that, which is that many people have tried to put a number on how much code is now being generated with AI. It took GitHub 17 years to reach a billion commits in a year. And now they're reaching more than a billion commits every single month. So even if AI is much better at finding bugs, it's entirely possible that it is simultaneously creating far more of them. More code might mean more logic flaws, which might mean new classes of vulnerabilities that we haven't seen before. So while we as defenders can use AI to help solve the problem, AI is also increasing the volume and the complexity of the same problem at the same time. Individually, these curves are somewhat manageable, but together, they're not. On one side, we have a system that is getting faster and faster, and on the other, we have organizations that are improving pretty slowly. While AI is driving faster patch demand, organizations still have human speed, slower execution. While AI is creating more vulnerabilities, organizations still have the same or even less budget and bandwidth and capacity. So, what you end up with is a system where demand for security work is accelerating, but our ability to respond is not yet. We as an industry have spent decades optimizing vulnerability detection. But what we haven't yet optimized is decision making at scale. And so that becomes the bottleneck. We are running AI speed, we're trying to run AI speed security operations on human speed, human understood systems. And that gap is potentially where things start to break because the assumption behind automation is that you understand the system you're operating on. What a concept. In most environments, that assumption doesn't hold. Automation without system understanding is chaos. We're automating chaos. Not because the technology is wrong or bad, but because our environments aren't ready. My brilliant friend, Kim Jones, said this bluntly in a briefing that he posted on LinkedIn earlier this month, which is that automation doesn't just fix broken systems, it amplifies them. And so when we layer AI speed response on top of incomplete asset inventories, fragile, broken integrations, and dependencies that nobody's actually mapped completely, then we don't get faster security, we get faster failure. This is not a failure of AI, this is a mismatch. And when systems are under that kind of pressure, they don't necessarily fail all at once. they can fail in very specific and very predictable ways. So, if that's the collision, what actually breaks first? The first failure won't be a breach, it'll be operational. Take something like automated patching. You apply a patch and something breaks. Not because the patch is wrong, because of unknown dependencies. And now you've created an outage at scale. We have always and will always wrestle with false positives. More alerts, more noise, more fatigue. We also will continue to have a problem with untracked systems and incomplete asset inventories. We can only protect appropriately what we know exists. And with all of this complexity, the gap between what we think we're protecting and what actually exists potentially gets wider. And going back to identity, even if everything else were perfect, attackers are still getting in through credentials because social engineering is so darn good at this point in time. It is easy for attackers to compromise credentials. So, what you get is not immediate catastrophic failure, but systems that break more often, generate more noise, and become harder to trust. What actually matters here is this stack, because if we're honest, the problem isn't the AI models. It's where we're focusing our attention and effort. We're arguing at the top of the stack while we're failing at the bottom. At the top is narrative, hype, fear, media. These are the least important, arguably, and the most discussed. Then is models. These matter, but arguably they don't matter the most. This is another conclusion from the Jagged Frontier paper that I think is exactly right. The thing to focus about in AI cybersecurity is not the model, it's the system around the model, the orchestration, the validation, the business workflows and use cases, the trust layer that decides which findings are real, which are prioritized, and which get acted on. Orchestration is where value starts, and operations is where organizations struggle. At the bottom is infrastructure. Back to basics. Foundational components, assets, data flows, dependencies, crown jewels. Everything above inherits the weaknesses below. You can't skip layers in this model. This is where you move from the model can do something to the system can produce a reliable outcome. In a way, this becomes a translation problem, turning signals into decisions and decisions into business risk. Because the shift that we're seeing here is not just faster tools, it's moving from reacting to alerts, it's operating with context and intent. I would like to advocate for visibility, transparency, and explainability before velocity. Business systems and workflows and processes over models. Identity as a priority. Automation that is controlled and understood. Because neither AI nor automation replace discipline and good hygiene. AI and automation just amplify those things. So if we take a step back and look at where we are right now, we've got a system that's accelerating and we've got organizations that are trying to keep up. The gap between the two is real. We don't get to choose whether this accelerates. We only get to choose whether our systems keep up or whether they break under the pressure. This isn't a moment in time so much as it is a pattern. And once we look at it that way, we can see that it's not just a speed problem, it's a decision making problem. And the organizations that can solve that and figure out how to do decision making at speed and at scale, these are the ones in my opinion, that can actually keep up. And then I start asking myself, is this the shift? And I start asking, am, am I and is my organization built to handle continuous change? This is what I think Daniel Miessler was getting at. Mythos isn't the event, it's the new normal. And the organizations that plan for this normal are the ones that stop being surprised. I believe that the future of cybersecurity isn't about having the best model. It's about whether an organization can operate at the speed that the models have already reached. And so my recommendation is don't optimize for the model, optimize for the system. Thanks so much for joining me.